Deviot13.mp4. We'll talk about all things small and big. Big hand of applause, please.
Good afternoon. I am Benjamin Kabe. I work at the Eclipse Foundation, and you might or might not know that we have lots of cool open source projects for doing IoT. And today I want to talk about lightweight M2M. Who knows lightweight M2M? Who's heard of it? Few people, well, a couple people. Who's heard of co-op? Maybe later, earlier this afternoon. Okay. So yeah, the idea is to talk about device management, and I don't have a remote, it seems. Okay. Well, the thing is, of course, the IoT, now we have all those cool protocols like MQTT and all those frameworks for home automation and so on and so forth, but how do you actually manage the device? Like when you have a fleet of devices, how do you reboot them? How do you set the settings, like the cellular modem settings? How do you manage the software that's running inside the devices, including maybe the firmware? How do you change the settings of the software that's running? How do you monitor that the device is communicating in a correct manner? Like you want to see how many bytes were sent and received and stuff like that. So you need to do device management, right? So usually what you will do is that you will have your devices on the field that run some sort of agent, ideally something that's built in the firmware and that will allow at any time from a device management server that the device is talking to do actual device management. So usually you will have, you will try to set up a secured communication, right? Either using certificates or using pre-shared keys. If your device is very constrained, that might be the best option. But yeah, the idea is that from the device management server, which might not actually be the server where your, I mean, if you're doing a smart thermostat, you might not host the actual data, application data might not live in the same server than the server that is being used for device management, but still you need to have this infrastructure, right? So there are a few standards. Some of them have been around for many years. You might have heard of TR-069. OMADM is what is used basically in all your cellular, in your mobile handsets, right? This is how the carriers upgrade the radio module in your device. And there's a new standard, a more recent standard called lightweight M2M. It also comes from the Open Mobile Alliance, the guys who did OMADM. And yeah, basically all those protocols are here to help you manage a fleet of devices. And no matter what is the actual software that you're running, you're really at a lower level. You want to manage the device, right? So lightweight M2M is built on top of co-op. OMADM, the previous version was HTTP, SOAP, XML sort of stuff. I mean, there were other transports as well, but it was very heavy. And lightweight M2M is really meant to be very lightweight. The fact that it runs on top of co-op means that, well, not only in terms of bandwidth, it's going to be very efficient, but it also means that actually you can have some funky ways of doing the actual transport of your device management packets in the form of short messages. Like if you want to bootstrap your device over SMS because, well, just the internet connectivity isn't there yet, you may use SMSs for that, right? Oh, looks like I have a duplicate. I knew I had it coming. So yeah, basically the idea is co-op is REST on top of UDP. You may or may not know, now you know that. So it's basically a very lightweight mechanism for doing REST, and basically what lightweight M2M does is standardizing a set of resources, as in HTTP resources, basically that you can get, put, post to update them, query their values. And what lightweight M2M standardizes is a set of objects, a set of resources, if you will, that have well-known names and attributes for accessing the battery level of the device, accessing the number of SMSs you sent, the SMSs you received. And there are other initiatives actually to also standardize resources like what is an acceleration, what is a temperature, what is a humidity. So these, this would be something that the guys at IPSO are actually standardizing. So the features in a nutshell, maybe one of the most important, maybe the most impressive as well, in that it really allows with a very lightweight protocol to do firmware upgrade, but in general you will use lightweight M2M for doing everything device monitoring, and you have also all the, it standardizes all the workflow to do the initial bootstrapping of the device. Typical use case is you leave the factory, the device isn't ready just yet, right? You're working on the new super awesome Nest thermostat. The hardware is ready, but the software stack, well, it's still full of bugs, and you want, you don't even know, maybe you don't have all your server infrastructure yet, but you know that eventually there will be, there is a cellular modem, or there will be a way to reach the device, so you will be able to bootstrap the server credentials over SMS, maybe, or over other means. So the standard objects, there is like 7 of them, I think. The device, the server, you might have actually several servers, fallback servers, or everything related to connectivity. The GPS location would be available as part of LightWebM2M as well. The firmware, and we will see that in the demo later on, and they all have super short numerical identifiers, as in like if you were doing HTTP gets on resources that are very short numbers instead of being like huge URLs. So yeah, an object like, say, a location will actually may have several instances. So that's how you would organize your resources hierarchy. If you're talking about a location is object number 6, and it's very likely that there's only one instance of a location, right, on your device. So /6/0/1, for example, will be attribute number 1 for your location, or attribute number 2 would be the altitude. What is nice with LightWebM2M is that you can query either a specific resource, or you can query or get or update directly a complete object at once by issuing a request on the instance. And in that case, you can retrieve a TLV encoded value, or since we are leveraging co-op in LightWebM2M, could also be any kind of content type, really. Could be JSON as well, although they might defeat the purpose of doing something that is lightweight. So in terms of open source implementations of LightWebM2M, so this, I mean, LightWebM2M is an Open Mobile Alliance specification, but it turns out that there are several companies actively working on providing open source implementations of LightWebM2M, licensed under the EPL and the BSD license. So those companies would be Sierra Wireless. They work on, I mean, they do cellular modems basically. Bosch, they do tons of connected devices. Zebra Technologies, they do connect devices as well. Gemalto starts getting interested. I mean, all those players collaborate on open source implementations. On the server side, there is an implementation called Leshan, which is basically a Java stack for building LightWebM2M servers. There's also work in progress for doing clients as well. It's very simple. It's not like based on Spring or on any complex framework. It's also providing a web UI for interacting with the devices. I mean, the server devices connect to the server, and then as an end user or as someone who wants to manage a fleet, you will interact with the devices using either the built-in web UI, using a web UI that you will build yourself, or using the REST APIs that Leshan is providing. So it implements most of the features of LightWebM2M, the bootstrap, the encoding, using the TLV system. It works well in OSGI containers. You have the security support. It's based on Californium, which is a Java implementation of co-op, and it has the whole DTLS stack, so you can do certificate-based, well, not yet actually, but you can do pre-shared key authentication, raw public key. And yeah, that's basically, I mean, it's very simple to build. The source code is available. There's also a sandbox that's available at lishan.eclipse.org if you want to test LightWebM2M, which we will do actually in the demo. I won't go through the code in details, but basically the API for building a server and for extending the server is really simple. You get nice callbacks whenever a new client is registered. You have basically a handler to the client, and if you want to update a specific value on the client, then basically you will create a specific request, a write request to update. In that case, that would be resource number 13, it seems. That would be the date. resource number 13 on object number 3, instance 0, so that's very likely the device object, and you can perform the actual request. So that's lesson. Client support is under construction. So you could also, if you are interested in running a Java lightweight M2M client, could do that as well. Project plan is, yeah, as I said, certificate-based authentication. The project is still in the process of moving to eclipse.org. Doesn't support JSON just yet. Doesn't support SMSs, but these are features that are in the roadmap for the project. Well, I have a similar slide at the end. On the embedded side, and this is where it gets really interesting, Wakahama is a C implementation of lightweight M2M that runs on very, very constrained devices, as we will see in the demo. It's a C client. It's not meant to be used as a shared library, right? It's a client that it's a set of files that you use to actually do a porting of lightweight M2M for your specific device. Basically, the only dependency is on sockets, right? You need to be able to open, close the sockets, and then send and receive on the UDP socket. So it's actually pretty easy to do the porting on most. I mean, on most devices, the API is very, if not POSIX, it's looking very much like POSIX. Maybe there is a different name for socket send, and you will just need to do a very simple porting. There's no built-in DTLS support in Wakahama. You have to provide that yourself. But again, I mean, on many IoT devices, you do already have support for doing DTLS. I mean, you have a hardware acceleration for encryption and stuff. So you're not that far from bringing your own DTLS implementation usually. Features that are supported, again, most of the lightweight M2M features. No JSON support here neither, but you can read resources, do the observe mechanism. I didn't mention observe before, but in co-op you can actually ask a resource to notify you whenever it changes, so you don't have to poll it regularly, right? And in terms of code, well, you do create instances of the objects by using the lightweight M2M, the Wakahama APIs. So what are the answers you want to provide to the read method, to the write method, to the execute method, etc., etc. And then you basically mount the resources in your all your objects and all your resources. You mount them in your lightweight M2M client. You establish the connection with the server, and if in your lightweight M2M client stack you have usually an infinite loop or a thread dedicated to making sure that anything that is received on the UDP socket needs to be handled by the Wakahama stack, right? So what is in the roadmap for Wakahama? Providing the bootstrap. They're working on more examples. There is one on GitHub for which we will actually see the demo. But yeah, the idea is to provide more portings to more devices. There is a testing server that's available as part of Wakahama. It's far from being production ready. It's really just used for testing purposes. But I mean, it might be interesting to have a C implementation of a lightweight M2M server to make it more scalable and such. And so yeah, demo time. Actually, there's been some work. I mean, the Bosch guys especially did work on porting Wakahama on many different devices. Not only, I mean, they do port it on their devices, and I cannot show you those demos, but they also ported it to several open hardware platforms. So today I want to demo Wakahama running on the embed. So the embed is a Cortex M0 Plus device, and the idea is that I exactly want to replicate the use case I sort of described earlier, where I'm working on a new super cool IoT gadget. The hardware is kind of ready, but the software isn't. So it's time to ship. It's time to leave the factory and to actually ship to the clients. So what's going to happen the first time the device connects, right? The software is still full of bugs, or is maybe not ready just yet. So what I'm going to show is the lesson web UI, right? So that's the built-in Lesson web UI. It's nothing fancy. It's really just meant for interacting with your devices. If you really want to build your own device management infrastructure, you will likely integrate Lesson in your own backend, right? But still, from this web UI, you can see all the connected clients. So this is the sandbox I was referring to earlier, right? Running on lesson.eclipse.org. You see all the clients. You can configure the credentials of your clients as well. Like if there's a pre-shared key that your device are going to use, you can configure the key or the keys from the web UI, or you could use an API as well. So that is my sandbox. That is my embed device. It's going to connect to the internet through I'm sharing the connection from my laptop, but I could have used a Wi-Fi capable device as well. So I'm going to turn it on. Just providing power. All right, device is turning on. And the only software that's running right now on the device is Wakayama. There is only, as part of the firmware, if you will, there is my Wakayama /LightWebM2M daemon, and at any time I can use Leshan to browse what are the standard resources, standard LightWebM2M resources that are available. So here we're talking about an embed device, an NXP micro, but it could be any other device, right? They would all expose the same standard resources. So if I'm interested in reading the device object, then I can retrieve the name of the manufacturer. I can retrieve the model number of the device, the serial number, the power, voltage, etc. So here I did read the wall content, but I could also read attribute by attribute. There could also be, in this example, there are only 3 objects that are made available by the device, but there could be more, right? If you remember the IPSO smart object stuff I mentioned earlier, you could decide that you are actually also exposing the temperature of the device as a standard resource, and you would know, it would allow anyone to actually discover the capabilities of the device easily because they conform to a standard description that is part of the LightWebM2M standard. So what I'm really interested in the context of the demo is the firmware object. The firmware object allows me to write either the package or the package URI resource. Most likely you will use the package URI, but the idea is to flash a new firmware, right? So you can do that in band. You can use UDP and CoAP. Not sure that would be a good idea, but you could try and directly write a new binary firmware into resource /5/0/0, or you can flash a new, change the value of the URI attribute to just provide the URI to a binary that is available somewhere on the internet and downloadable through HTTP or FTP or whatever. So in my case, the name of the binary would be that one. It's hosted somewhere on a server. I want to update the value of the attribute. Where am I? All right, I did update the value, but the update is going to happen as soon as I start clicking the exec method, right? So right now the device is actually downloading the new firmware. It's going to reboot when it's done, and we will see that we're going to turn this device into a more useful device in the form of a device. So in the meantime, it actually lost the connection with the server, right? That perfectly makes sense. And now we actually have a device that blinks an LED, but it's also now running a complete, a real application that allows me to control and to display the values of the temperature of a demo that we have on the Eclipse Foundation booth, and I retrieve the temperature using MQTT. So I'm basically running at the lower level, I'm running a Wakayama LightWebM2M stack for everything device management, but on top of that, I can do whatever I want. In my case, that is running an application that uses an MQTT embedded client and update the status of the LCD depending on what are the MQTT messages I receive. And for those who have a good visual memory, we can see that now that the device is back. If I ask for the device information again, the model number that is being reported is different from earlier. Now I'm basically running a totally different application. So that's basically the demo. A few more examples of running Wakahama on very constrained devices. The Spark Core, you might be familiar with the Spark Core. It's an STMicro Cortex M3, 20 Ks of RAM, 128 Ks of flash. And the Bosch guys, what they did is that they ported Wakahama for the DTLS. For the security support, they ported tiny DTLS with pre-shared key support. So they are not exposing a shitload of lightweight M2M objects. They just expose the device object, but that's still, I mean, that's still useful for retrieving battery level and the like. So an empty firmware, basically an empty app on the Spark Core would be 75 Ks of flash, 13 Ks of RAM, and adding the lightweight M2M example, that is Wakahama plus tiny DTLS, is an overhead of only 3 Ks of RAM, 32 Ks of flash storage, right? The U-Blocks, it's actually compatible with the embed APIs, only it also does GPRS. So in this case, they ported way more objects. They are exposing the server information, security information, firmware, etc., etc. And the complete application is the real-time OS plus the command line interface plus lightweight M2M, and it's in the range of 80 Ks of flash, 22 Ks of RAM. Yes, I'm actually through the presentation. So Arduino Mega, same sort of footprint. There is a Lua binding for if you want to do, I mean, for easing the DTLS integration, you could do that using Lua APIs rather than providing a DTLS at the C level. Mailing lists to report bugs and questions that you can ask right now if you have any. Yep.
Is there an M4 implementation of the Wakahama or Texas Instruments CC3?
That is a good question. Yes, question is there support for M4 devices like the TI CC3200? I did start to do the porting. I think it would be, it wouldn't be a big deal. I mean, when I was describing that on most platforms, porting the socket layer is actually very simple. That's the case for the TI platform. Like all the socket methods are basically, instead of doing socket send, that would be SL underscore socket send or something. SL being simple link, they are a network stack. So no, that would be an interesting port to do. I mean, I'm sure this would fit in the CC3200 is not that constrained as far as I remember. So if you do the porting, please just tell me that'd be great. Yeah.
Or the other way around.
Are there other questions? Yeah?
Is this possible to run on ESP8266?
It is possible to run on ESP8266. Well, I don't read Chinese, so I guess it could be possible, right? I just did. I mean, I was kind of joking, but that is true, right? It's kind of hard to find the proper support for the device, but as far as I remember, the memory available and stuff would totally be in the range of what I described earlier, right? So that would be yeah, that would actually be quite interesting to try that and to.
European vendors making ESP now, so
Yeah.
ESP models.
Yep.
Makes sense.
Yep. Yep. Yep.
If UDP is used as a transport, is there a limitation on the message size?
Yes, there is. So that's what you may have seen in some slides. There is in co-op there is an extra layer for doing block transfers. Like if you want to send large chunks of data, you would need several co-op / UDP packets, right? So that is supported by the protocol. Do we have time for one last question?
I'm
Or?
going to cut you because we all
Okay.
cut everyone at the same time.
Okay.
No discrimination. Thank you very much, Benjamin. Thanks. If you want to stay, we have an open